is one more paper. Take it. Take it.
Let's start that again. Can everybody hear me? Am I audible? Okay, so for grade 10, okay, this is grade 10. We are actually going to look at something slightly different from what I had said we are going to look at. We are going to look at products, finding products, all right? We're going to revise the multiplications of monomial by a binomial and trinomial and binomial by a binomial, and we're going to look at the multiplication of a binomial by a trinomial. All right, that's what we're going to do today, and this will be a session that we will do before we go into factorization. So for today we are going to look at products, and we are going to look at, specifically as per your ATP, we are going to look at a monomial by a binomial. 2, we are going to look at monomial by a trinomial, binomial by a binomial, and then lastly binomial by a trinomial, in that order. Okay, and maybe just to give you guys a sort of an example, if we're looking at monomial by a binomial, generally speaking, this is when you have one term multiplied by two terms. Okay, so this would be monomial, one term, and this would be, inside the bracket we have a binomial, that's two terms. Monomial by a trinomial, this would be like taking a monomial, one term, multiplying by three terms. Okay, trinomial. Binomial by a binomial, this would be typically a plus b into c plus d, so that's two terms multiplied by two terms inside the brackets. And then last but not least, binomial by a trinomial, that would be like two terms multiplied by three terms. So we are going to look at these because according to your annual teaching plan for grade 10, the second section of work that you guys do is algebraic expressions involving products, firstly. So algebraic expressions involving products, okay? And then after that you do factors. So we are going to start with products, okay? And we are going to look at these, okay? So hopefully you guys understand what a monomial is. Monomial means an expression with one term, and then binomial means an expression with two terms, okay? Trinomial, on the other hand, means an expression with three terms. All right, so let's go, guys. Let's go. So for number 1, we're looking at monomial by a binomial. Okay, so this is just grade 10, guys. This session is a grade 10 session. For those who are looking for a grade 11 session, please go to my page. All right, my page itself, this TikTok page, actually has the schedule for today. All right, and there on the schedule you'll find what it is we'll be covering and when we'll be covering grade 11. It's later on this evening, so just check my schedule, the schedule that I posted yesterday of how things will go for today. Okay, so for monomial by binomial. So let's just look at this general example. Here we have a into b plus c, all right? And what I usually like saying to students is that whenever you are dealing with these, what you need to understand is that we are applying something that we refer to as the distributive law, using something that we refer to as SNL. The distributive law using SNL. What does S stand for? Sign, N, number, L, letter. So we are applying the distributive law using S, sign, number, letter, multiplying the sign first, multiplying the number next, multiplying the letter next. There are a few things we need to understand with the sign first and foremost. Multiplications of signs. A positive times a positive when it comes to signs gives us a positive. Hopefully we all know that. A negative times a negative gives us a positive. A positive times a negative gives us a negative. And then a negative times a positive gives us a negative. We need to all know what the combination of signs, the product of them, what it gives us. Okay, so if we have 2 addition signs multiplied, we'll always get a positive. In fact, let's just say an even number of positive signs will always give us a positive answer. An even number. That means if you have 2 addition signs multiplied, you'll get a positive. If you have 4 addition signs multiplied together, you'll get a positive. If you have 6 addition signs multiplied together, you'll get a positive. All right? But we can always check, man. You see? So for instance, if I have positive times a negative, you know that a positive times a positive will give you a positive. Then that positive times a negative will give you absolutely a negative. All right? Okay. Also, a negative times a negative times a negative. If you want to check that one out, what does it give you? First and foremost, you check what is a negative times a negative. That gives you a positive. And then a positive times another negative will give you a negative. Okay, so all in all, you need to always just check the combination of signs when multiplying each other. Okay, so that's very important. Okay, so what I'm saying here is that an even number of positives and negative signs multiplied together will always lead to a positive answer. Okay, and then for different signs, just always remember that if you're multiplying a positive and a negative, so for instance here you're going to get a negative. A negative times a positive will give you a negative. Okay, so that's for signs. Then numbers. All of you should be able to utilize this beautiful instrument called the calculator whenever you are at loss with multiplication of numbers. Some of you don't know your multiplication timetables off the top of your head, so you need to utilize the calculator. Then lastly, letters. With letters, we need to remember laws of exponents, okay? And that is, if you are multiplying same bases, the bases are the same. We know that the answer is we must keep the base, which is a in this case, and then we add the exponents together. So that would be like saying m plus n, because the bases are the same. So that is for multiplication of same bases, right? So for example, x to the power 2 times x to the power 3, we know will be equal to x to the power 5. Why? Because when we are multiplying same bases, we keep the base and then we add the exponents, right? Very important. Okay. So that's law number 1 of exponents. Law number 2 says when we divide same bases, all right? We keep the base, we subtract the exponents. So that would give us an answer of x to the power 3. All right. So these laws are very important, and we need to remember them when we do these sorts of problems. Okay. Multiplications of signs, multiplications of numbers, multiplications of letter. And yes, you are right. There are many other laws, but for the purpose of what we are going to do, law number 1 and law number 2 are very important. Okay? Very important. Kaume nawe kitu. Right. So just generally, this monomial by a binomial, we distribute the a to the b. The variables are not the same. What's a times b? ab. What's a times positive c? ac. So basically, we would have an answer of AB plus AC. Why? Because we distributed the A to the B, but when we distributed, we remembered that there's a sign that A and B have, which is positive. A positive times a positive gives us a positive, so that's why our answer is positive. There's a number. Before A, there's a 1. Before B, there's a 1. 1 times 1 gives us 1. The number is sorted. Then there's the letter. A times B. For different bases, we simply combine the letters together, and we have an answer of AB. All right. Likewise, with A times C, there's a sign, positive times a positive, which is positive. There's a number, 1 and 1. 1 times 1 gives us 1. And then there's a letter, A times C, which if the letters are different, the bases are different, we combine the letters together to get AC. And because these are unlike terms, we cannot add them together. We leave them as they are. So like terms can be added or subtracted, but unlike terms cannot be added or subtracted. Okay, so like terms can be added or subtracted, but unlike terms cannot be added or subtracted. Hence, we leave the answer in this state. Right. So we are going to now go and look at specific examples related to monomial by a binomial. Let's go. First one, 2 into x plus 3. Okay. So what do we have here? 2, a monomial. In brackets, x plus 3, a binomial. So what do? We apply the distributive. We apply the distributive law using S and L. 2 distributed to the x. 2 times x. So in other words, 2 is positive. X is positive. Positive times a positive gives us a positive answer. Number. 2 times, there's a coefficient here that is 1. We don't see it, but it's there. What's 2 times 1? It's 2. The x next to the 2 combined with the 2. That is the first term done. 2 times 3. Positive times a positive is positive. Sign. Number. 2 times 3 is 6. There's no letter, so therefore there's no need for us to write any letters. So the answer is 2x plus 6. Are these like terms? No, they are unlike terms, so our answer is 2x plus 6. We cannot add or subtract unlike terms. Example 2. X into x minus 3. Monomial by a binomial. So this term 2x, this one x, this one minus 3. We apply the distributive law using S and L. Distribute 2x into x. Apply sign multiplication, sign of multiplication. Positive times a positive is positive. Number. 2 times, there's a 1 here. 2 times 1 is 2. Letter multiplication. X times x. The bases are the same. So what do we do with multiplication of same bases? We keep the base. There's a 1 and a 1 there. They are there, but we cannot see them. It's like God. God is present, but unseeable. 1 plus 1 gives us 2. Right? So our first term is 2x squared. Then we take 2x, we distribute it to negative 3. Sign, number, letter. 2 positive times a negative gives us a negative. Number. 2 times 3 is 6. Letter is x. So we combine it with the 6. So our final answer is 2x squared minus 6x. These are unlike terms. Why are they unlike terms? Because this x has the exponent 2. This x has the exponent 1. The exponents for the same variables make it so that the terms are unlike, not like. So therefore we leave our answer as 2x squared minus 6x. We don't have to write that exponent 1, but I wrote it because I want you guys to understand that these are unlike terms simply because the exponents are not the same. If they were the same, the exponents for same variables, we would add the like terms, but these are unlike because the exponents are different. I hope we are clear. We do not, as it says, unlike terms cannot be added or subtracted. So that's why we leave the two terms as they are. We don't go further. Example 3. Two xy into x squared minus 3y. So once again, we apply the distributive law using S and L. Let's go. 2xy into x squared minus 3y. Monomial by a binomial. So we take 2xy, we distribute it to x squared. Then we use the sign number letter. 2 is positive. X squared is positive. This is grade 10, Miss Jackie. term 1 next year. Products, revision of multiplication of monomial by a binomial. That's what we are doing at the moment. Week 2 of term 1, grade 10. Positive times a positive is positive. Then we move on to the number. 2 times, there's a 1 here. 2 times 1 is 2. Then we move on to the variable. Now in the letters we can see there's an x and there's a y. So we start first with the same variables, x. X times x squared. That means x to the power. We have a 1 here, we have a 2 here. So what does that mean? It means we keep the base, we add the exponents for the x. So that means 1 plus 2 is 3. Y is alone. So there's no other y for the first term, so the y is written next to the x cubed, combined with the x cubed next door. That's the first term. Then we take 2xy, we distribute it to negative 3y. 2xy times minus 3y. The 2 is positive, the 3 is negative. What's positive times a negative? Negative. Then number 2 times 3, that is 6. Then later, x is alone. So we write x alone because there's no other partner x on the other side. So we write x as it is. Then y. Y is not alone. There's a y here and there's a y there. So y times y. We keep the base, we add the exponents. There's a 1 and there's a 1 there. So that means 1 plus 1 is 2. We look at the terms. 2x cubed y minus 6xy squared. Are the terms the same? Are they like terms? No. So we cannot add or subtract unlike terms. So we leave the answer as 2x cubed y minus 6xy squared. So I hope you guys understand this. Okay? I hope we understand this. Now let's move on. We've done example 1, we've done example 2, we've done example 3. This all was in explaining monomial by a binomial. And maybe let's do one more example just to sort of like put right. Okay, thank you so much, Book Nostalgic. Really appreciate the first. Okay, let's look at this one, guys. We have 2x monomial by 3 over 2xy squared minus 7x. So this is also a monomial by a binomial. But look at this first term. It's a fraction. Unlike the first 2-3 examples that we did, there were no fractions. But all of a sudden now we have a fraction. Okay, nothing to it. We still have monomial by binomial, so we are going to apply the distributive law using S and L. Two x times 3 over 2xy squared. Firstly, sine. Positive times a positive gives us a positive. Then number, 2 times 3 over 2. Okay, remember this is like saying 2 times 3 over 2. This 2 is in the numerator and this 2 is in the denominator. So this 2 and this 2 can cancel. So which will leave us with 1 times 3, which is 3, and 1 times 1, which is 1, which is actually 3. Okay. Or you could take your calculator and punch this in. 2 times to make life easy for yourself. 3 over 2 equal. Look at the answer. There it is. Okay? So really and truly, 2 ways of doing this. Then you just simply go ahead and you punch in 3. Okay? Because you simply went to your calculator and said 2 times 3 over 2, your calculator gives you 3. Makes life very easy so that you don't have to think much. Then, that's the number, done. The sign, positive. Letter, x times x. We keep the variable base, x. We add the exponents 1 and 1, which gives us 2. Y. Y is alone. There's no other y this side, so we just combine the y squared next to the x squared. That's our first term on the left. Okay. Move on to the next one. 2x times 7x. 2 is positive, negative 7x is negative. So positive times a negative, negative. Number, 2 times 7, 14. Letter, x times x. Keep the base, we add the exponents, x squared. Right? Then, are these like or unlike terms? They are unlike terms. Why are they unlike terms? Even though you can see x squared here and you can see x squared here, this one has y squared, so you cannot add these two. So you have to leave the answer like that. Okay? So hopefully we are good to go to the next type. So we've just exhausted monomial by a binomial. Now we can move on to, monomial by a binomial. Now we'll move on to monomial by a trinomial. Wait for what, Matsetse? No, I can't restart. Matsetse, I can't restart because this is time, right? You can subscribe to my YouTube channel. I will upload this video step by step. What I've just done, you will see it in the YouTube channel. The YouTube channel is called Maths is a Game. You can go to the YouTube channel, Maths is a Game. You can go to my bio, go to the YouTube icon that's there, the one that has a red background and a white play. You can click on it, go to it will send you directly to the YouTube channel. It's called Maths is a Game. I will be uploading this session as soon as I'm done with it. Then you can rewatch it at your own pace, your own time, and that's good. Okay, I have to move on because I'm on a time budget here. Okay, remember, I'm doing this for free. You're not paying me anything to have a session like this, but you can go to the YouTube channel and rewatch the session. All right. So let's move on to the next part, which is your monomial by a trinomial. Okay. So here we are. Monomial, one term by a trinomial, 1, 2, 3 terms. Remember, what separates terms is a plus and a minus sign. Okay, so we have a one term with 3 terms inside the bracket. So let's go. This is no different from what we've been doing. We simply distribute the 3 to the 3 terms inside the bracket using S and L. S and L simply means we distribute. DL means distributive law, by using multiplications of sign first, multiplication of number second, multiplication of letters last. And we need to remember, when you multiply letters, we remember law number 1 of exponents. So let's go. 3 times x. First and foremost, the sign. 3 is positive, x is positive, positive times a positive is positive. We go on to the number. 3 times, there's a 1 here. What's 3 times 1? It's 3. Then we follow it with the letter. There's only x there, so we write x combined to the 3. That's our first term. Move on to 3 times negative y. We first multiply the signs. Positive times a negative, negative. Number. 3 times, there's a 1 here. 3 times 1 is 3. Then we follow it with the letter y. Y combined to the 3. This is grade 10. Last one. 3 times a negative 3. Positive times a negative, negative. 3 times 3, 9. There is no letter, so we don't write any letter. The answer, 3x minus 3y minus 9. Very tempting to want to subtract these, but can we subtract 3x minus 3y minus 9? Look at 3x, variable x. Look at 3y, variable y. Look at negative 9. It's a constant term. So these three terms are unlike terms. Can we add them? No, definitely, Landy, where you are right. So we leave the answer as 3x minus 3y minus 9. Right? Let's go. Okay, so that was example A. Let's look at B. The next one. Okay, once again, monomial by a trinomial. One term, 3 terms. Refilwe, look at my schedule. On the home page, you will see when I'm doing grade 11 today. 3x into x squared minus 3y minus 7 over 3. Follow the live create, and then you can actually go onto my, like I said, go onto the home page. You will see there's a schedule there. The most recent video I've posted is of the schedule of the sessions that we'll be having today. I've already done grade 9. This is now grade 10 that we are doing. This is the work that you will cover in week 2 of term 1, all right, for the first 3 days in the second week. So 3x into x squared minus 3y minus 7 over 3. We apply the distributive law, meaning 3x into x squared, 3x into minus 3y, 3x into minus 7 over 3. You can go to my YouTube channel, subscribe there. The video will be uploaded after this session for the grade 9 session that I did this morning, and as well as the grade 10 session that I'm currently doing. I'll upload those onto the YouTube channel. Go to my bio, click on the icon, the YouTube icon, go and subscribe, and then all the notifications that come on for the uploaded new videos, you can see them there. All the sessions that I've done last week as well for the grades grade 8, 9, 10, and 11 are already there as well. Okay, so distributive law using the sign, number, letter. In other words, we're going to multiply the signs, multiply the numbers, multiply the letters. Let's go. 3x into x squared. Firstly, the signs. Positive times a positive is positive. We are done with the sign. Move on to the number. 3 times, there's a 1 here. So 3 times 1 is 3. Then we move on to the letters. X times x squared. Variables x squared. The bases are the same, so we keep the base. We add the exponents. There's a 1 here. We can't see it. It's always there. It's like God. It's 2 there. We add the numbers. 1 plus 2 is 3. Okay, so we have 3x cubed for our first term. 3x to the power 1 times negative 3y. Same thing. Sign first, we multiply. Positive times a negative is negative. Number, 3 times 3 is 9. Letter, x times y. We combine the different letters to become xy. Second term, done.
Close. Close. Close the door. This one. Close the door.
Okay, so like I was saying, yes. Okay, so like I said, this was positive times a negative is negative. 3 times 3 is 9. Then x times y is xy. Okay. Then the last term, 3x to the power 1 times minus 7 over 3. sign first. Positive times a negative is negative. 3 times 7 over 3. Now, all you need to do is just say, if you don't know 3 times 7 over 3, then you can say equal. There you have it, guys. Multiplication of the fractions that maybe are complicated to you. Just punch it into your calculator. 3 times 7 over 3. You get a nice, beautiful answer of 7. And then there's a letter x. So that letter x is combined with the 7. Okay, final answer, here we are. Guys, this is an early Christmas gift to those who are like wondering, hi Bo, a couple of days, early Christmas gift, guys. Me having these sessions with you is just me saying to you, happy Christmas, Merry Christmas. I want to lessen your anxiety for next year, for all these grades. You guys will be on fire. You'll only appreciate the gift that I'm giving to you now, even though it's painful next year when you do the things, you know, especially if you can master this work. Just hang on, I just need to close the door. Even more reason why Tandegang goes, even more reason. It's December, it's Christmas season. I'm giving free gifts. That's free lessons. Are you kidding me? Alright, so there we have it, guys. 3x cubed minus 9xy minus 7x. And are these like terms? No, they are not. So we cannot add or subtract unlike terms. So we leave our answer like this. The x here has to the power 3. The x here has to the power 1, but it's combined to y. So it makes this and this unlike because the y makes it unlike. This is 7x. Alright, it has no y. So there's nothing that you can add or subtract here. You must leave the answer in this form. Okay. Let's look at another one. One more. One more. Okay, let's look at this guy. Hipster kunovela ku FYP page. I'm happy. It means that's good. Negative 3 over 4x cubed y into how many terms in the bracket? 3. 5 over 9x to the power 7y minus 2 over 6x squared y plus z. Not complicated at all, guys. If you have this guy, if this guy is here, it's easy. It's just easy. Once again, distributive law using SNL. 3 over 4 we are going to distribute to 5 over 9x to the power 7y. What do we first start with? The sign. Negative times a positive. That will give us a negative. Finished. Okay. Then we move on to the number, the fractions. 3 over 4 times 5 over 9. Go to your calculator. Access this button, this one. Then you type in. The sign is already taken care of. So all you're caring about now is the numbers. 3 over 4 and 5 over 9 times 5 over 9. There you have it. All you do is press on equal. There it is. Calculator simplifies it for you. So you have 5 over 12. Done with the number. Let's move on to the letter. Letters, x to the power 3 times x to the power 7. Bases are the same. We keep the base. We add the exponents. 3 plus 7 is 10. Y to the power, there's a 1 there. I always say it's like you don't see God, but he's there, guys. Things that you see, but they are there. They are there, these things, but you can't see, or he or whatever, it's there, but you can't see. Y, we keep the base, we add the exponents. 1 plus 1 is 2. Grade 10, grade 10, grade 10, grade 10. This is grade 10. First term done. Next term, 3 to the power 4, 3 over 4, we multiply with the second term. Sign, negative times a negative is positive. We move on to the number. Thank you so much for the heart me, I really appreciate it. Number. So the sign is taken care of. All we have to take care of now is the number. 3 over 4 and 2 over 6. So let's go. 3 over 4. Okay, let's just remove all of this because we started wrong. 3 over 4 times 5 over 9. 5 over 9 equal. Sorry, that was not 3 over 4, 5 over 9. It's 3 over 4. Remember, the second term is 2 over 6 times 2 over 6. Yeah, we shouldn't get too excited that we make errors that are unnecessary. There we have it. The answer is 1 over 4. So we have positive, the sign was taken care of. The number now is taken care of, it's 1 over 4. And then we move on to the letter. X cubed times x squared. We keep the base, we add the exponent, so this is x to the power 5. Then there's y. Y and y to the power 1 times, there's a 1 there, we know. So we keep the base, we add the exponents, it's y to the power 2. Next, the last one, negative times positive z. So negative sign, negative times a positive gives us a negative. Then we go on to the number. 3 over 4 times, there's a 1 before the z, it's always there, we cannot see it. 3 over 4 times 1 gives us 3 over 4. Then last but not least, the letters. X cubed is unique, y is unique, and z is unique. So these are different letters, so we write them combined next to each other. X cubed, y and z combined. Then we underline. All right, you would use a straight line and underline. These are all unlike terms. Can we add them? No. So we leave the answer as you see it. Are we together? Are we together? Are we together? Man, I hope we are together. All right. All right. Okay. Now, that is monomial by trinomial. I hope you guys understood what monomial by trinomial is. I'm just going to do one crazy example just very quickly because I want to see if I can't sometimes you get questions like this. 4 minus 3a minus 7 over 3, and all of a sudden you have, let's just say this is 4x, and then all of a sudden you have the number this side. Okay, remember in grade 8 and 9 you guys learned that multiplication is commutative. In other words, the order of the terms when you multiply does not matter. In other words, a times b. Mamolimo, you can. I mean, no problem. Okay, I always hold sessions. Just please subscribe. I'm sorry. You can actually follow the live creator, and then I post the schedule every day as to how the sessions will be. For now, I'm having grade 9s have sessions at 7 a.m. and then I'm having grade 10s at 8:30. Right? So this is how I'm going so far. Okay, so let's look at this. A times B is the same thing as B times A. Oh, my God. I love you, Aurora Trends. You are so lovable. I love all these people. A times B is equal to B times A, guys. Please go on to my... please go on to the TikTok page, the main page. You'll see basically. So A times B is equal to B times A. The order doesn't matter. We still get the same answer. So whether it's 3 times 7 or 7 times 3, we're still getting the same answer. Are you with me? So here we have it. 4x minus 3a minus 7 over 3 into 8. Okay, this is still a trinomial by a monomial. So this 8 still, you can, if you want to, just for the sake of order in your head, you can just write it in the sort of like right order, because like I said, multiplication, the order does not matter. So if you put the 8 before the bracket, it's fine. All right, all we know is that the 8 needs to be distributed to the 3 terms. All right, yeah. So like I said, this is grade 10. So we distribute the 8 to the 3 terms, sign, number, letter. Okay, so 8 times 4x, positive times a positive is positive, number 8 times 4 is 32, letter x. Then 8 times negative 3a, positive times a negative is negative, then 8 times 3 is 24, and then the letter a. Then last but not least, 8 times negative 7 over 3, positive times a negative is negative, 8 times 7 over 3, once again you can just take your trusted calculator if you want to avoid the thinking process. 8 times 7 over 3, there's the answer, it's 56 over 3. And there you have it. Okay, that would basically be your final answer, right? So please people, that basically brings us to the end of monomial by a trinomial. Okay, aren't we taking a sign of a bigger number? I don't understand what you mean by that, Blackie. The sign of a bigger number. All right, like I said, we are multiplying here. Remember, with multiplication, there are laws for signs. A positive times a positive is positive, a negative times a negative is positive, a positive times a negative is negative, and a negative times a positive is negative. So here we are, here you can see that 8 times 4x is 32x, 8 times minus 3a, positive times a negative, negative 24a, and then 8 times negative 7 over 3. You multiply and you get negative 56 over 3. These are all unlike terms, we cannot add them, so we leave our answer as it is. Okay? Yeah. Okay? There's no like terms, we can't add anything. Okay, let's look at type number 3. Binomial by a binomial, multiplying a binomial by another binomial. Okay, so generally speaking, a binomial by a binomial is addressed using a law that we refer to as FOIL. FOIL simply means the following: when we multiply, we are going to simply distribute and multiply the first terms first. In other words, a times c. These are the first terms in each bracket. We multiply the first terms first. So this would be like saying a times b, which we know gives us, so not a times b, because this is a times c. So this would be like saying 8 times c. When letters are different, we simply do what? When we multiply, we combine the letters together. Multiplication combines different letters. So this is a times c, which simply gives us ac. But remember, when we apply the multiplication, we remember who? S, N, L. In other words, we multiply the sign, we multiply the number, we multiply the letter. So we get AC for our first term. So we multiply our first terms in each bracket first using S and L. 2, we multiply our outer terms. In other words, A outer, D outer. So this A also gets multiplied to D. It's like you are distributing A to C and then you're distributing A to D first. That's basically what we are doing. Distributive law using S and L. So A times D gives us A times D. A is both positive. A and D are positive. So positive times a positive is positive. 1 times 1 gives you 1. We can write that 1 there. It's always there. It's like the unseen. You know what I mean? So A times D gives us AD for the letters combined together. Okay? That's the outer. Then we multiply the inner terms. In other words, the second term distribute to the first term. Positive times a positive, positive. 1 times 1 is 1, b times c is bc. Then we take the last terms in each bracket, meaning b and d. We distribute b and d. So, using S and L, positive times a positive, keep positive. B times D, give BD. So we have AC plus AD plus BC plus BD. And this all comes from what? It all comes from taking our binomial, multiplying by another binomial. Okay? So we get these 4 terms. And then basically what can we look at? Do we have any unlike terms? No, we don't. No, we don't. So therefore we leave our answer like this because we don't have any like terms. If we had like terms, we would add those like terms, but we don't here. Yeah, so those are the 4 terms, 1, 2, 3, 4 terms, and basically that is our answer. So just a reminder again, whenever you are doing a binomial by a binomial, you are multiplying your first terms, you're multiplying your outer terms, you're multiplying your inner terms, and then you're multiplying your last terms. And then if there are any like terms, you add or subtract those like terms. If not, you leave those terms as they are. And basically that's how you do binomial by a binomial. Okay, so we are going to look at an actual example because this one was just a general example. Okay, so let's look at an actual example. Let's say we had x plus 3 into x plus 2. So let's look at this. So hopefully you guys see now that we are going to apply FOIL, meaning the distributive law, using S and L. FOIL means multiply the first terms first. So first terms first, meaning x times the x. Using S and L, positive times a positive gives us a positive. 1 times 1, because the coefficient of 1 for x and x, 1 times 1 gives us 1. Move on to the letter x times x. Keep the base, we add the exponents. There's a 1 and a 1 there. What do we get? It's x to the power 2. Okay, so that's our first term, using the first terms multiplied together. Then we distribute x to positive 2. So x times the positive 2, a positive times a positive. The sign first. Positive times a positive gives us a positive. Sign taken care of. We move on then after that to the number. Okay, so that means 1 times 2 gives us 2. We move on to the letter x. There's no other letter this side, so that means it's 2x. We combine the 2 and the x. Then we move on to our inner terms. Apply distributive law, S and L. Sign, number, letter. Sign first, positive times a positive, positive. Number next, 3 times the coefficient of x is 1. 3 times 1 is 3. Letter next, there's only x, so x is combined to the 3. Then last but not least, 3 distributed to 2, positive times a positive is positive. 3 times 2 number is 6, no letter, so we leave it because there's no letter. Then we inspect our terms. We've got 1, 2, 3, 4 terms. The 2 middle terms are like terms. Why? Because the variables are the same. The exponents are both 1, so therefore we can add or subtract the 2 middle terms. These are like terms. So let's go ahead and finish off this answer. X squared, what's 2x plus 3x? The rule when we add like terms is that we keep the variable, we add or subtract the coefficients. The coefficients are the numbers before the variables. So plus 2 plus 3 is going to give me plus 5, and then I have plus 6. So this is x squared plus 5x plus 6 This is a beautiful trinomial that I get, which is my final answer. Are we together? Okay, so that is a example where I have a binomial by a binomial. Okay, let's look at another one. Okay, let's look at this one. X minus 4 into x minus 3. Okay, so again, what are we going to do? We are going to apply FOIL distributive law using SNL. SNL means sign, number, letter. FOIL means F. F stands for, we multiply the first terms together. X times x, applying SNL, number, sign, number, letter, positive times a positive gives us a positive. Number 1, there's a 1 there, times another 1 gives us 1. Letter, x times x, bases are the same. We keep the base whenever we are multiplying same bases. We add the exponents. There's a 1 and a 1 there. That means 1 plus 1 gives us 2. So we have x squared. X times negative 3. X times negative 3. Positive times a negative, negative. 1 times 3, that is 3. X variable next door to the coefficient. Then we take the inner terms, negative 4 times x. Negative times a positive, negative. 4 times 1, the 4 and the 1 gives us 4. X combined next to the 4. Then last terms, negative 4 times negative 3. Negative times a negative is positive. 4 times 3 is 12. There's no letter. Therefore, final answer, x squared, what's negative 3, x minus 4x. These are like terms, so I can add like terms. And people, sometimes this becomes so dangerous. Some people butcher it here. Because why? They cannot add and subtract integers properly. Please, people, if you are not sure, I would suggest a calculator. We know that the variable will stay the same. We need to simply now what? Negative 3 minus 4. Take your calculator, please, if you know you are going to butcher it. Negative 3 minus 4 gives you negative 7. Please, people, type it in. We know that it's the coefficients that we deal with. Negative 3 minus 4 gives you negative 7. So we have negative 7x plus 12. The last thing I want to see is people messing it up at the end. Okay, right? If we do all the steps correctly, the maths should maths, man. It should maths. It should really maths. We can't say maths is not mathsing all the time. Maths must maths. You know, it should get to a point where maths needs to start mathsing. You know, if you know what I mean, right? Let's look at another one. Example 3. X plus 7 into x minus 3. Okay. If you've noticed something here. For these brackets, I had the same sign, plus and plus. For these brackets, I had the same signs, minus and minus. Now I'm just doing an example where the signs are different. Okay? I mean, really now. FOIL. First terms. First terms. This topic for grade 10 is called algebraic expressions. It's done in week number 2 of term 1. And it usually starts with a revision of multiplication of monomial by a binomial, which we've done. Then it's followed by monomial by a binomial, which we've done. And then it's followed by binomial by a binomial, which we are currently doing now. Then after that, it's followed by multiplications of a binomial by a trinomial. And then when all of that is done, they jump into factorization. So today we are just going to focus on the monomial by a binomial, monomial by a trinomial, binomial by a binomial, binomial by a trinomial. And then tomorrow we'll start with factorization. So x plus 7 into x minus 3. Yes, Christmas Eve, guys. We'll start with factorization. Okay. X plus 7 into x minus 3. So let's check this out, guys. X plus 7 into x minus 3. FOIL. X times x, x times x. Oh, and for those who have joined in for the first time, you are literally in a maths channel where we strive to basically establish maths concepts and principles early, especially for those who will be going to a certain grade next year. I've already started beginning last week with the grade 8s, 9s, 10s, and 11s. So we've been doing these sessions every morning in the week. There's a YouTube channel called Maths is a Game that you can subscribe to. All the sessions I've done last week are already uploaded on the session. Very raw, guys, unedited. What you see basically is the raw, unedited version. I upload the video lessons exactly as you see them right now. So what I'm saying now, you'll hear me say it even in that YouTube video. I don't edit anything. So you can jump on there, check it out. Yeah, you can say the answer, Tinswalo, please do. Please, you can hop on there, go and watch the videos that I've done. I'm doing the work starting from the first topics of each grade for term 1. So your learner or your child will not be disadvantaged at all. You can go on there, and also there are follow-up exercises that I usually post, and I usually do those as corrections for the next session, so that we can actually make sure that we are all on par and on the same page. So it's not too late. Anyone can catch up if they want to. They can hop onto my YouTube channel and can watch the sessions that I've done so far. And I'm following the ATP guys for next year. So it's important. It's very key. So x plus 7 to x minus 3. I know someone is going to give me the answer very shortly. First terms first. So x times x, positive times a positive is positive. 1 times 1 is 1. X times x is x to the power 2. Outer terms, x times negative 3. Positive times a negative. Positive times a negative is negative. 1 times 3 is 3. Then x combined. Inner terms, positive times a positive is positive. 7 times the coefficient 1 is 7. And then x combined. Then last but not least, 7. Positive 7 times negative 3. Positive times a negative is negative. 7 times 3 is 21. There is no variable. Okay. Then lastly, final answer, we have actually got what? We've got like terms in the 2 terms in the middle. So negative 3x plus 7x will give us plus 4x minus 21. Okay. Yeah, guys, sorry, I just had to attend to something very quickly. Yeah, otherwise, I was here all along. It's just that I had to attend to something quickly. Okay, so guys, I hope we got x squared plus 4x minus 21. Please, guys, please don't take for granted this minus 3 plus 7. Go ahead if you need to. Go punch it into the calculator and say minus 3 plus 7. So that you do actually write the actual coefficient answer, which is positive 4x. It's so sad when I see learners, even the learners that I teach at my school, when they actually take for granted the addition of these middle terms, and then they come up with some answer that is completely off. You know, it's such a pain. Okay. No, but Duga, we can't go to Euclidean geometry after this. I'm following a program. Please, people, those who are joining into my session, all right, I understand that you may have your own sort of like desires about what needs to be done, when and what. Right now, what I am doing, I am following the ATP, the annual teaching plan for next year for the respective grades. So those who actually follow up and follow through and join the sessions, and if they miss the session, they go to the YouTube channel Maths is a Game and actually go ahead and follow through with that, you know, then those people will actually, as they go along, we are trying to eat an elephant here, but we are not we are not rushing to something that will, you know, complicate life. We are taking it one step at a time, right? So please, I understand your desire. Maybe you are fine with this and Euclidean geometry is your pain. If you want private lessons with me, just contact me on the side and we can talk about that, and I can jump into your specific problem area that you have, but there will be a fee attached to that. So, you know, that's for private lessons. So please, let's do that. But for those who are going on the public sphere, we are doing want free things, then let's be on the same tip here. Okay. Someone asked, where did I get the negative 21? So let's take it through once again. We multiply the first terms. First, x times x, we get x squared. We multiply the outer terms next, x times negative 3. Okay, we get negative 3x. Then we take 7 and we multiply with x. Okay, positive 7 times 1x gives us 7x. Then we multiply the last terms last. So positive 7 times negative 3, that's positive times the negative gives us negative. 7 times 3 gives us 21. That's where we get the negative 21 from. Then after that, we add and subtract the like terms, our middle terms, and like I said, please guys, do not mess things up here. Make sure to get whatever you get in the middle term. Okay. So yes, guys, what we are doing whenever we multiplying a binomial by a binomial is we are multiplying the first terms, multiplying the outer terms, multiplying the inner terms, and then multiplying the last terms. Okay. Okay, so 1, 2, 3, 4. We distribute, multiply using S and L. Then the last example, the second last example for binomial by a binomial, which I want to do, is this one. X minus 9 into x plus 4. It's called algebraic expressions, okay? Algebraic expressions. And the subtopic is finding the products, okay? Finding the products. Products means multiply, okay? So we look at how to multiply a monomial by a binomial. We've done that already. Multiplying a monomial by a trinomial. We look at multiplying a binomial by a binomial. And then we are going to lastly look at how to multiply a binomial by a trinomial. Okay, so we are currently on binomial by a binomial. Okay, trigger, I do not do maths literacy. This is only pure maths. On this page, I only do pure maths. I don't do maths literacy. Okay, unfortunately, it seems like it's the pure maths students that are struggling, so that's why. Okay, let's go. X minus 9 to x plus 4. So once again, first term, distribute to the first term, 1. Then first term, distribute to the outer term, that's 2. It's like x needs to be distributed to both. Then after we are done, minus 9 to the first, that's the third. Then minus 9 to the last. Does that make sense? That's what we're doing here. So let's do it now. Let's apply S and L sign number. Let x is positive, x is positive. Positive times a positive gives us a positive. Then 1 and 1 is here. 1 coefficient of x, 1 as a coefficient of x. 1 times 1 number is 1. Then let x times x. We keep the base for x. Then remember, when bases are the same and we're multiplying, what do we do with the exponents? There's a 1 here and a 1 here. And I've made reference to what I compare that with. We keep the base, we add the exponents. 1 plus 1 gives us 2. That's why we get x squared. Okay? Okay, Trigger, I understand. That's good. You're very thoughtful. Okay? Then x times positive 4. Positive times a positive, positive. 1 times 4, 4. X is combined to the 4. Move on to this one. Minus 9 times x. Negative times a positive, negative. 9 times 1, 9. X is combined to the 9. And then last but not least, negative 9 times 4. Negative times a positive, negative. 9 times 4, 36. Okay? Then we finish off by adding our like terms. Plus 4x minus 9x, please people, it's plus 4 minus 9. So if you don't know calculator, 4 minus 9 equal negative 5. Answer, x squared minus 5x minus 36. Beautiful answer, x squared minus 5x minus 36. Feel me? I hope you guys feel me. I hope you guys have the feels. All right? Okay. I hope you guys have the feels. I hope you guys can feel the feels. Trigger's saying there's still like terms there. Okay, Trigger, tell me, which like terms do you see here? Okay, I have a feeling that you will actually tell me something that I've explained already, but I'm happy to explain that again. Where are the like terms, Trigger? You're triggering me with your comment. Oh, sorry, I thought I saw 36x. Oh, okay. Because you nearly triggered me with your comment, eh? You nearly triggered me, Trigger. All right, here we are. 2x minus 5 into 3x plus 4. Okay, here's another beautiful, nice example. So we can go ahead and we can move along here. So 2x times 3x. So once again, FOIL, first, outer, inner, last. First, one, outer. So 2x we distribute to the 3x first, and then 2x again we distribute to the 4. You see, so basically we exhaust distributing 2x, and then we exhaust distributing 5. Okay, because we are applying what we refer to as the distributive law, but we just call it FOIL for convenience. Okay, so let's go. Numbers, sign first. 2x times 3x, positive times a positive, positive. So our term is positive. Then number, 2 times 3, 6. Letter, x times x, we keep the base, we add the exponent. So 1 and 1 gives us x squared. 2x times 4. What if both was negative? Then you would say negative times a negative is positive. Do you see, Tina? Okay. If both was negative, you would basically say negative times a negative is positive. So that's why I always in my head, I go over the signs, the numbers, the letters. I don't take for granted the type of sign that is there for each term. So you always take that into consideration. When you multiply, you apply S and L, sign, number, letter. You multiply the signs first, you multiply the numbers next, you multiply the letters last. Make sense? So 6x squared. 2x times 4 now. So positive times a positive, positive. 2 times 4, the number, 8. X combined to the 8. Negative 5 times 3x. Negative times a positive, negative. Number, 5 times 3, 15. Letter, x next door. Then lastly, negative 5 times positive 4. Negative times a positive, negative. 5 times 4, 20. Finally, 6x squared. What's 8x minus 15x? Take your calculator. If you are not sure, please. You know that the variable will stay as x. All you need to now do is add and subtract the coefficient. What's 8 minus 15? So you don't want to butcher this. So we say 8 minus 15, negative 7, negative 7, negative 7x. Minus what? Minus 20. Okay. Okay. All right. So I hope we are good, guys. I hope we are good. Hey, I hope we are good. Hope we are good. Okay. Hope we are good. 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 All right. So I hope this is actually going nicely and well and so forth. I just want to do this one. This is also another binomial by a binomial, but it's hidden. Do you see what we see here? 3x minus 2y, and look at this, the whole thing squared. Now some people usually make a mistake here, and they usually do this. Inside you can see most, these are unlike terms. So some people usually do this nonsense, and I'm just going to write the nonsense down. They say the answer here is 9x squared plus 4y squared. Okay, this is the nonsense that people usually do. Why? Because what they do is they say you square the first term, so you get 9x squared. And then they say you square the last term, you get 4y squared. And then they say the answer is 9x squared plus 4y squared. This, guys, I want to say is rubbish. Why? Because inside the bracket we have how many terms? There are 2 terms. And we have an exponent. So basically what we should have done is 3x minus 2y into 3x minus 2y. We open the number of brackets that we see the exponent tells us. If there was 3 here, we would open 3 brackets. Since there is 2 here, we open 2 brackets. Then what do you see here? The multiplication of these 2 things means we apply now what we call FOIL. Are we together, people? Because, hey, that nonsense that people do here, this rubbish, hey, it's a problem, this rubbish. But we can't have this rubbish as something that we do, okay? So please take note of the nonsense. And then take note of the beauty. The beauty of the beauties of all beauties. All right? Then let's go. I'm sure you guys know what needs to be done. We apply FOIL, distributive law, applying SNL. So let's go. 3x times 3x, 3 times 3. We know positive times a positive, give positive. 3 times 3, give 9. Killer, stop killing our people here and writing give December. Stop killing our people here. I see the knife you have there on your profile picture. You are a killer. Now you want to kill us here in the live by your negativity. Come guys, come on guys, come on. Let's be positive here. Okay. Yeah. This is a Christmas gift to all those who want to have a good feeling next year. This is a nice Christmas gift. It's coming early on the 23rd. So please come down. Positive times positive is positive. 3 times 3 is 9. Then letter x times x key 9x squared. So thank you very much, Landy, where you spot on. Then 3x we distribute to negative 2y. Positive times a negative, negative. 3 times 2, 6. X times y, combine the letters next to the 6, negative 6xy. Next, negative 2y times 3x. Negative times a positive, give negative. 3 times 2, give 6. Y times x, give yx, or you can write it as xy. Remember guys, whether you say yx or xy, we learned most that multiplication is commutative. Yx is the same thing as xy. Whether you wrote xy or yx doesn't matter, people, because multiplication is commutative. All right? In other words, the order of the letters for multiplication is the same. So If I wrote minus 6xy and here you wrote minus 6yx, it's the same thing, guys. It's fine. It's still the same thing. Okay? Still the same thing. Then the last term, negative 2y times negative 2y, negative times a negative, give positive. 2 times 4, 2 times 2, sorry, give 4. Y times y, take note. Bases are the same. You keep the base, you add the exponents. Okay. I think some people coming into this session are very rude. Michelle, yeah. I wonder which school do we go to, or like how have we been raised? Guys, manners are important, okay? How you conduct yourself is very important. Let's try and be respectful. If you come into the live and you feel like, oh, this guy is doing maths in December, I understand where you're coming from, okay? Because people should be relaxing, should be chilled, it's all good. I understand that. But don't be rude on my live. Don't come here and say nasty and what you might call rude things, okay? Be respectful. You are allowed to be shocked about us doing maths now. It's okay, but don't be rude in the process, all right? Okay, let's go. So now we can add the like terms. These are like terms, guys. Whether I had written yx or xy, it would still be like terms. Because remember, like I said, multiplication is commutative. Yx is the same thing as xy. All right? There's still an x here, there's still an x there. There's still a y there, there's still a y there. These make it like terms. All right? So therefore, our final answer will be 9x squared, middle term, minus 6, like I said again, let's go to the calculator. Minus 12, minus 6, say minus 6. You see this? You punch it into your calculator, minus 6, say equal. Calculator gives you an answer. Negative 12, guys. Negative 12xy plus 4y squared. Chwa, pagati inside. Kamura. Okay? Right? Kamura. Right? Inside. Right, inside pagati, guys. Inside pagati. What more can you ask for? All right. Okay, then the last thing I'm going to do for today. Then tomorrow we'll pick up something else, still related to finding products, but today I just want to end with this. Now we are going to look at the last type, which is your binomial by a trinomial. Binomial, two terms by a trinomial. Guys, they usually do trinomial by trinomial as well. Sometimes they do that, all right? And honestly speaking, when they do that, it's just that they just want to check if you understand the whole concept of distributive law. Okay? Right. I will not do more of these types, guys, now. I'm going to do other types now, right? I've been doing binomial by binomial. Okay, let's do one more, because you guys are insisting you want to do one more. Let's do this one. Let's do this. Okay, let's do this one. Let's check this out. Grade 10, guys, grade 10. So this is still a binomial. This is also a binomial. Two terms in each bracket, right? You can see inside this bracket, there's no like terms. Inside this bracket, there is no like terms. So let's go. We apply FOIL again. Okay, this by that. Let's go. Sign, negative times a negative, give positive. 3 times 7, give 21. X squared times x, these bases are the same. So what do we do when we are multiplying same bases? We keep the base. This is 2, there's a 1 here, so we add the exponents. Variable y, unique and distinct, combine it with the x cubed. Okay, so we have 21x cubed y for the first term there. Okay, then okay, let's just change this plus. Let's change it to negative so that we can just accomplish a purpose of some sort here. Okay, so like I said here, guys, negative times a negative, we start with the signs, we multiply, we get a positive. 3 times 7, we get a 21. X squared times x, Remember, bases are the same. So we keep the base x, we add the exponents when we are multiplying same bases. We get x cubed. Then y is unique, so we write it next to the x cubed as another letter next to the x cubed because there's no same base y on the other side. Done. Now we can move on to negative 3 times negative 3 over 7. How did you get 2? Which 2 are you talking about? Okay, this is 21. Negative times a negative, positive. 3 times 7, give 21. X squared times x to the power 1. When you are multiplying same bases, you keep the base, you add the exponents. What's 2 plus 1? It is 3. Then y. Y is combined because there's no other y on this side, so the y is combined with the answer that I had gotten as a variable. Then we move on to the next term. Negative 3x squared y times negative 3 over 7. Once again, negative times a negative, positive. All right? Then 3 times 3 over 7. You take your calculator. We've already finished taking care of the sign, right? Now we're moving on to the number. 3 times 3 over 7. So we simply just go to our calculator and say 3 times 3 over 7. Then we say equally. Then we get 9 over 7 as the answer for the fraction. So we write down 9 over 7. Right? Then the letters x squared y. Okay? All right? Then let's move. 3x now we have to multiply with negative 7x. Positive times a negative, we start with the sign, is negative. We move on to the number. 3 times 7, 21. We move on to the letter. What if I write 12? I don't understand. Short tree. What if I write 12 over 7? I don't understand what that is. I don't understand what you're talking about. Short tree says, what if I write 12 over 7? 2 over 7. Where did you get 2 over 7 from? I don't understand. I don't understand at all where you got 2 over 7. Oh, you mean, what if you wrote 1, 2 over... So, if you wrote it as a mixed number. Oh, I hear you. All right. Yeah, let's keep it to the improper fraction. Okay, let's keep it to the improper fraction. Right, I understand what you mean, but let's keep it to the improper fraction for the purpose of just getting the answers immediately and initially. All right, I understand the mixed number, but let's keep it to the improper fraction. You wouldn't be wrong if you wrote that, but let's keep it to the improper fraction as much as possible. Okay, so we multiplied 3x times negative 7x. So positive times a negative is negative. That's the sign. Then we move on to the number. 3 times 7, 21. Then x times x. Keep the base x. What do we do to the exponents? We add them. This is 1, this is 1. So that means 1 plus 1 gives us exponent 2. Then we take 3x, we multiply by negative 3 over 7. Start with the sign. Positive times a negative, give negative. Then you take your calculator for the number. 3 times 3 over 7. Oh, remember, 3 times 3 over 7 gives us 9 over 7. 9 over 7. Then the x, the letter, we write x next door as the variable because there's no other complementary variable of x, so it is what it is. Now look at this. This term. Is there any like terms that we can see here? Any like terms, guys? Doesn't seem like we have any like terms, guys. So I would say that our answer basically can be left like this because there are no like terms. Wow, specific. Yeah. When people are learning and you are not, then we need to call upon him so that he can assist us to have the attitude at this time. I'm just trying to be Santa, guys. I'm trying to be Santa in this season and really help people. This is an early Christmas gift. I thought we love early Christmas presents, guys. You know, We are here for that. All right, so that's that example. Lastly, now we are going to look at binomial multiplied by a trinomial. Okay, I'm going to look at two examples where that is concerned, and then I will end the live. We are doing grade 11, term 1, guys. Look at my schedule. Please go onto my homepage, go to my schedule. The most recent video that I posted is off the schedule for today. I did grade 9 earlier on, busy now with grade 10. Grade 11 is coming up later on sometime today. You just need to go and check out the schedule for today. And for those who are joining in for the first time, who are like, what in the world is happening? This guy is doing maths in freaking December. Are you kidding me? Yes, I am, guys. I've started an early start, get ready early program for the kids in the country. Why? Because I'm concerned about the maths performance in the country, guys. And I know some of you are like festive season, but it's okay. The reason why I'm doing it, I have selfish reasons for doing it because I'm concerned about the performance of students in maths generally. So if I can help in any way, whether it's now or later on, I'm doing it. Okay? And these are free live sessions that you can join. I upload the sessions after they are done onto the YouTube channel. You can check it out. The YouTube channel is called Maths is a Game. I've uploaded the lessons and the sessions I've done last week. So you can check them out on there. It's just raw videos as you see them, raw live sessions as you see them. And yeah, I do it because I love maths and I love seeing people do well in maths. Okay, let's go. A plus B binomial by a trinomial. Let's look at binomial by a trinomial. So this is just an example, obviously, generally speaking. What do we do when we are dealing with a binomial by a trinomial? When you're dealing with a binomial by a trinomial, we do nothing different from what we've been doing already. A as the first term needs to be distributed to how many terms? This side. A as a first term in the binomial needs to be distributed to how many terms here? How many terms do we have inside this bracket? There are 1, 2, 3 terms. So what we are going to do is we are going to simply distribute A by multiplication, by multiplication, by multiplication. Does that make sense? So we distribute A 3 times. Then after we're done, we take positive B. We distribute him how many times? 3 times. Does that make sense? So this is basically what we are doing. In everything we've done here, all we have been applying is that law called the distributive law or the distributive property that you guys learned in grade 8. We are applying it practically now for the purpose of being able to simplify and get our answer. So this is what you would do. You distribute using still what? S, N, L. You multiply the sign, you multiply the number, you multiply the letter. So what would we get here? Okay, like I said, please go onto my homepage to know when we are doing grade 11. I have posted the schedule for today when we are doing each grade. Please go onto the schedule. But unfortunately, if you are in grade 9 and grade 10, I'm busy with grade 10 now. I did grade 9 at 7 a.m. this morning. So A times C will give us positive times a positive is positive. 1 times 1 gives us 1. And then we get AC. We combine A and C. It's like the part in it. A times C is AC. A times D, A times positive D. Positive times a positive gives us a positive. 1 times 1 gives us 1. And then A times D gives us AD. A times E. Positive times a positive gives us a positive. 1 times 1 gives us 1. A times E gives us AE. So AC, AD, AE. Then you take this B, you distribute it to the C, B, you distribute it to the D, B, you distribute it to the E. So we are going to have BC plus BD plus BE. And all the way through, what did I do? I applied SNL. Then I check, do I have any like terms? And you can see, guys, AC is nothing like it, AD, nothing like it, AE, nothing like it. So generally, there's no like terms. If there are no like terms, then obviously I end right there. But if there were, then I would actually add like terms. Okay, so guys, this is basically binomial by a trinomial. We're just distributing using SNL. We use the distributive law. We multiply the signs, we multiply the numbers, we multiply the letters, and then if they are like terms, we add them. If they are not, we leave them, all right? And we leave the terms as they are, okay? So I'm just gonna do 2 examples, and that would be it for today, guys. So first example. Okay, but I will be posting, don't worry, I'll be posting the session that I did of grade 9 in my YouTube channel. So you need to go to the YouTube channel, Maths is a Game. YouTube channel, Maths is a Game. Yeah, it's there. Please tell me when you, okay, so YouTube channel, Maths is a Game, guys. Maths is a Game, that's where I upload all the sessions that I do here. All the sessions that I did last week as well are already uploaded on that YouTube channel. You can check it out. I'm following the maths, I'm basically following the maths ATP for each respective grade for these sessions, okay? So I'm gonna call you now, okay? Okay? You want to play with? Okay. I'm gonna call you guys now. Please close. I'm gonna call you now, in a few minutes. I'm gonna finish, okay? Yeah. Just Alright, sorry, those are my kids there. Thank you, Smart Study. Okay, so here we are. Binomial by a trinomial. So 2a times a squared, 2a times 6ab, 2a times minus 6b squared. We apply SNL as we distribute. All right, you know most must study. We have the YouTube channel. You can always check out the session. I'll upload it later on so that you can catch what you missed. Unfortunately, I will be ending the session in the next 7 minutes, 10:30. So that's as far as I'll be pushing it for today. But I will be uploading what I did today. Don't worry, later on. I'm sure before 12 it will be on there. Okay. So 2a times a squared, guys. 2a times a squared. So we multiply using SNL. Positive times a positive gives us a positive. 2 times the coefficient of a squared. Thank you for the heart me and thank you for the TikTok Smart Study. I really appreciate it. 2 times 1 is 2. Okay, that's the number. Then the letter. A times a squared. We keep the base, we add the exponent. So there's a 1 here, there's a 2 here, so that will be 2a to the power 3. Okay, so far I hope we are together, guys. Okay, that will be 2a to the power 3. So once again, we multiply the signs first. Thank you for the ice cream. Positive times a positive is positive. 2 times 1 is 2. A to the power 1 times a to the power 2. We keep the base a. We add the exponents a to the power 3. We move on. We multiply now 2a with the second term in the second bracket. 2a times 6ab. So we multiply the sign. Positive times a positive gives us a positive. Sign done. Number 2 times 6, 12. Done with the number. Letters, variables. A times a, it means we are going to keep the base for a and add the exponents. There's a 1 there, there's a 1 there, so we go to get a to the power 2. This is grade 10. Then last but not least, There's a b there, but the b is alone, so we write the b combined with a squared. Okay, so far are we together, guys? This is grade 10 for those who are joining in. This is a grade 10 session. And please don't accept the invite. The person that I extended an invite, it was by mistake. I was trying to actually approve some comments that are in the comment section. Please don't accept the invites, guys. If I mistakenly send an invite to you, don't accept the invite. So 2a cubed plus 12a squared b is what I have for distributing 2a to a squared and then distributing 2a to 6ab. Now I'm going to distribute 2a to the very last term in the second bracket. So positive times a negative, negative. 2 times the coefficient of b squared is 1, is 2. And then a to the power 1 times b squared will be written as ab squared because we combine different bases together. Okay, so far 2a, when we distributed it to 3 terms, we have 3 terms. Now we move on and we take 3b and distribute it to the 3 terms. So once again, sign, number, letter. Positive times a positive gives us a positive. Number 3 times 6. 3 times 6 gives us, 3 times 1. Because we said 3 times positive times a positive is positive. That's positive. Then we have 3 times 1. That is 3. Okay. Then b times a squared. We can write in the order of the alphabet a squared b. All right. Okay. I just do it for convenience. Write it in alphabetical order. A comes first before b. So a squared b. Even if you said b a squared, that's still fine. Okay. Okay. Then we move on to 3b. We multiply 3b with 6ab. Once again, positive times a positive gives us a positive. 3 times 6, we get 18. B times ab. Now, b and b have same bases. Okay, but a is alone. So we write a and then the b times b. B to the power 1 times b to the power 1. We keep the base, we add the exponent, so it's b squared. All right, because the b here has an exponent 1 and the b there also has an exponent 1. So when we multiply same bases, we keep the base, we add the exponent, we get b squared. This is grade 10 for South African maths. Then last but not least, we take 3b, we multiply it with the last term in the other bracket. What is positive times a negative? It is negative. What is 3 times the coefficient of b squared, which is 1? It is 3. And then last but not least, what's b to the power 1 times b to the power 2? It's simply we keep the base. What about the exponent? It's 1 plus 2, which is b to the power 3. C. 1, 2, 3, 4, 5, 6 terms. As it should be, because we took 2, we multiplied it to 3 terms, which should give us 3 terms, the first 3. And then we took 3b, we distributed it to 3 terms, which would give us the next 3 terms. So in total, we have 6 terms. And you know what? I know for a fact that I've done everything accurately because every time I multiplied a term with another, I paid special attention to the multiplication of the sign, what I get, the multiplication of the number, what I get, the multiplications of the letters, what I get, which is so important, guys, when you do these questions. You want to be 100% accurate. And then we are going to now add and subtract like terms. You did this in grade 8 and 9 where you learned how to add like terms, how to identify like terms. So 2a cubed is unique. It has no like term friend. 12a squared b on the other hand. All right, I just do this for the purpose of this. You know, you don't have to do this. 12a squared b. Who is 12a squared b's friend? Positive 12a squared b's friend. It's not 2ab squared. It looks like it could be, but it's not. 3a squared b. Oh, they are friends. They are friends. Hello, friend. A squared b, we are friends. What about minus 2ab squared? Where is minus 2ab squared friend? It's here. It's plus 18 AB squared. So they are friends. So I can see these are like terms. Guys, you don't have to do this thing of circling and square. I'm just doing it so that I can see that, oh, they are like, all right? I'm just doing this as a device to teach you. When you answer a question, please, you don't have to. But if it helps you, please, by all means. All right, so 12a squared b, I know that when I add like terms, I basically keep the variable. So a squared b I know is going to feature in the answer whether I like it or not. But what I'm concerned about, plus 12 plus 3. What's 12 plus 3? 12 plus 3 is positive 15. So I have 15a squared b. That is when I added plus 12a squared b and plus 3a squared b. Let's move on. Minus 2ab squared and plus 18ab squared. I know my answer will have ab squared in it. The variable will stay the same. What I need to check is the addition of the coefficients. So that means minus 2 plus 18. If you don't know, please go to the calculator. Minus 2 plus 18. Answer 16 plus 16ab squared. Then this guy is alone. Minus 3b cubed. Guys, that is it. That is how we take care of a binomial by a trinomial. It's just distribution. So guys, I'm not going to do more examples. I'm going to end right here. I'm going to hold the horses right smack bang here. What I'm going to do is that on the TikTok page and also in the respective groups, I hope my group admins are here, the people who are actually running the WhatsApp groups, who are heading the WhatsApp groups. I hope you guys are here. Please, if there are people that are in grade 10 that are here, please do add them. And then please, right, someone who is the admin for that group needs to send me a message here on TikTok and tell me, sir, this is the link for the group so that I can join that group, guys, and be part of it. Okay, if there's other additional things that I can assist with and help with, material, the works, then I can assist you in that group. So the grade 10 group, please, someone who is the admin for that grade 10 group, please let me know. The grade 11s already have their WhatsApp group, and I am actually actively participating in assisting them when there are specific things that they need. I think there are 115 members or 130 members in that grade 11 group, and I love their attitude. What I also love is that they are helping each other with other subjects as well. So life sciences, because obviously I'm just helping with maths, but amongst themselves, there's other people that are good, maybe in other subjects, and they are able to help each other and assist each other, with those specific things. I think they've also started other branch groups for their respective subjects, which is good, and I love that. So, I really loved what another learner actually said in the group yesterday, because apparently they are so ahead in the syllabus. They are even way ahead of what we are doing because they are pushing. So I really love that kind of attitude. So, if you surround yourself, the saying, birds of the same feather flock together. If you surround yourself with, a certain group of people, then those certain group of people can influence you for good, and this is what I love in this season, Yeah, it is a season to be jolly, fa la 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 la, Christmas gifts and everything, but I think one gift we can give ourselves as a learner, is to actually have a positive attitude towards education. So I love what's happening there. So the grade 10 admin who's running that WhatsApp group for grade 10, please do send me a message on TikTok, at least with the the link for the group, for your WhatsApp group, so that I can join and be part of that, and assist where I can, with other specific things, because I can't always be live, but maybe I can send a voice note there and there to clarify something, whatever the case may be. And please let your parents know about this, because this is above board. This is not in any way anything besides me trying to help and assist learners across the country with maths, which is very key for me. I think a learner, if they are confident with their mathematics, it can actually help rub off that kind of attitude in everything and every other subject. So please, guys, whoever is the admin for the grade 10 group, let me know. I think the grade 9s as well, I've already actually entered that group for grade 9s as well. So the grade 10 group, you just need to send me the link, like I said, guys, so I can be part of that. And then, yeah, we'll take it from there. I will be posting, then I can also send you guys specific exercises and maybe other material as well as it relates to your subject. So please, guys, please, let's push. You guys are doing great. I really love and appreciate what you guys are doing for joining the lessons and joining the sessions. Thank you so much as well for the gifts that you guys are positing there every once in a while. I really appreciate it. And please do take care. I hope this session was really beneficial and helpful for you guys, and I hope you will join me tomorrow as well as we continue the fight for maths victory. Level 7, guys, we settle for nothing less than level 7. This is kind of also a hope that when we do these things early, it really helps cultivate the sort of confidence that can give us that boost of saying, Asuka, maths, easy this thing. So I'll be posting some what you might call game challenge. We call them game challenges because maths is a game. It's not homework, it's game challenges. So I'll post the game challenge exercises for you guys onto the TikTok page as well after I'm done, so that you guys can do that, and then I'll do those corrections the first thing that we do tomorrow as well. Sometimes as well, if the group is there for WhatsApp, then I can also do the corrections and send you guys the corrections in your WhatsApp group, so that the sessions can purely just be about me teaching you guys and nothing else, So let's do that. Who is the WhatsApp admin? I think Landiwe knows the do-abouts of that admin group. Landiwe 38, guys. I'm just gonna, let's do this. Let's pin the comment where Landiwe 38 is actually knows the do-abouts of the grade 10 WhatsApp group. So Mbali, you can just get in touch with Landiwe 38 there. I've pinned, I think he sticked up his hand to Stort Tree there, or Stort Tree, whatever that name is, to basically indicate that here I am, the WhatsApp person. So you guys can join that, and then you guys can speak positivity, man, in each other's lives, and also, just like I said, I love what's happening with the grade 11 group. I like the positivity that's happening there, and I like the fact that they're helping each other with other subjects as well. Official Porsche, grade 12, I'll only start with grade 12 officially tomorrow, New Year's Eve. What a great, Christmas Eve gift. Grade 12, I'll post, when I post the schedule today, the grade 12s will feature, so you'll know exactly what time with grade 12. Okay, so yeah, thank you guys. It was good, it was great. I don't do physics, I only do maths. Currently only focusing on maths. I want to focus on one thing for the end of this year and next year, and then I think as time does go by, when I have the experiential knowledge, because the thing is with maths, guys, I don't want to blow my own horn, but I am an expert when it comes to maths. And it's not because I'm blowing my own horn, it's simply because I've had the experience. It's been a couple of years teaching mathematics at high school level, grade 8, 9, 10, 11, 12. I'm a marker as well. I mark the end of year grade 12 maths papers. So what I'm doing, I know sort of like what's what, call it what you want. So that's why I'm doing what I'm doing. I'm doing it voluntarily, freely, so that you guys can get the benefit of this. It still hurts me so much to see learners not do so well in mathematics. Level 7 is a possibility, guys. 100% is a possibility in mathematics. You can do it, but it needs someone who can consistently play the game, right? Remember when you played that game that really was such a struggle for you, just a game on the phone, struggle at the beginning. You play the game, like, oh my goodness, when will I ever get a hang of this? And then with time, what happens, right? With time, you get better and better. The more you play the game, the more you get familiar with the moves, the controls, like what you do, when you see the boss, how you jump and all of that. The more you get familiar, the more you play it, the easier it becomes. And when you finally figured it out, it's like light bulb moment, and you're like, man, this is easy. Why was I complaining to begin with? So this is the same thing I believe about maths. The more you play it, the more you master the concepts, the rules, the more you figure it out, the easier it is. The grade 11 group is like I said, it's pumping, it's going, it's moving at a very fast pace. All right. It's unfortunate that I don't have my admin guys for the grade 11 group on the live at the moment, but later on today when I do the grade 11s, all right, please go on to the main page of this TikTok page. Just check out the schedule. When I'll be doing the grade 11s, I'll be going live with the grade 11s. When I go live for the grade 11s, then they will actually hook you up to the WhatsApp group so that you know exactly. Or you can just send me a message on the side. I'll send you the link for the WhatsApp group. And then later on this evening, when I have the session with the grade 11s, just check the schedule. Then you can also be in tune with what else is happening with them and what they are doing. All right. So thank you so much, guys. It was great. Official Porsche, thank you so much. It was good having you as well. To all the new people that came in, it was good having you. Know as well, I have a YouTube channel, like I said. It's called, sorry about that. It's called Maths is a Game. You can go on to the YouTube channel, Maths is a Game. Go on to my bio. Click on the YouTube icon. It will send you directly to the page. I'll be uploading these live sessions as well onto the YouTube channel. Then also you can just move forward, because all this commentary makes the video longer than it should. But you will be able to go to where I start teaching, and you can watch the video and enjoy that. Okay. Thank you so much. Thank you. All right. And Landiwa, thank you so much for what you're doing as well with the group, with the grade 10 group. Thank you so much. That's phenomenal. And then, like I said, send me the link, guys, of that group so that I can also join in that group of yours. And we can start speaking good life for mathematics for ourselves so that level 7 has possibility. Thank you, guys. Let me love and leave you. I'll just give Landiwe a chance there to just sort of like collect all these details. So I'll let the live roll. Inbox Landiwe better. Inbox. Right. Okay, inbox. Please inbox, Sham. Can you imagine? The group, grade 10 group, I've pinned Landiwe at the top there. Just inbox Landiwe your details and Landiwe will add you to the group. Landiwe 38. You can see the pinned comment. That's the person for the grade 10 group. Okay, guys, I'm going to have to close this live session. Hope you guys don't mind. Thank you so much again, and till next time. Next time we'll continue on where we left off, and then we'll branch into factorization of polynomials. So but I'll also be posting the homework on the TikTok page as a slide videos. So also check that out. Also, if you are in that group, Landy will also send me the WhatsApp link. I'll also post the homework or the game challenge. Sorry, let's call it. It's not homework. The game challenge that you guys need to pass through so that you can ensure that you are able to enter into the next session, which is the next stage of our game. Okay. Thank you guys for the follow as well. All right, let me love and leave you guys. Thank you so much, ne? Till next time.